Hi girls. So here I am again, just trying to do a question this time based on what we talked about recently about moles. And I'm going to start with a relatively easy one. Okay, it's a good place to start if you're finding moles a bit of a struggle. This is an ordinary level question. It's from 2013 and this is question 10b. So it's a good idea maybe to read through it first, to stop the video now, find this question in your papers or on study clicks. And also another thing to maybe look for is the template that we used for moles questions, because I'm basically going to be following that template. In fact, I've already done step one here, as you can see. So in this question, if you have it in front of you, you'll see that we're told that sodium hydrogen carbonate decomposes to form sodium carbonate and water and carbon dioxide. And we're told that we have 8.4 grams of sodium hydrogen carbonate at the start. So the very first question, part A of this question, or part B, part one, if you know what I mean, from the papers, says how many moles of sodium hydrogen carbonate were used up. So basically what it's asking us to do is to convert this mass into moles. And the way we do that, as soon as we know that we've got mass, is we're going to go to our periodic table. It's the very first thing we're going to do. And we're going to find out what 1 mole of sodium hydrogen carbonate weighs. And when we do that, we find that we've going to have to use the molar mass of 1 atom of sodium, 1 atom of hydrogen, 1 atom of carbon, and 3 atoms of oxygen, like that. So that's 23 plus 1 plus 12 plus 16 times 3. And when we put that into our calculator, we get 84 grams. So 1 mole of sodium hydrogen carbonate, 6 by 10 to the 23 particles of sodium hydrogen carbonate, will have a mass of 84 grams. But we've only got 8.4 grams. So we want to know how many moles that is. So how do we do that? We take the mass we have and we divide by the molar mass. So we go 8.4 divided by 84, and that gives us 0.1 moles of sodium hydrogen carbonate. Like that. Okay, so that tells us that we've got 0.1 moles of sodium hydrogen carbonate to start with. I can write it under there if that helps, like that. All right, now, the next thing that we need to do, the next part of the question asks us what mass of water is produced. So, as we know, our units in chemistry are moles. So we need to figure out, first of all, how many moles of water are produced from 0.1 mole of sodium hydrogen carbonate. So we're going to have to use our molar ratio. So this is step 3 in our 4-step template that we used. Okay, so in this case, the molar ratio is 2 to 1. We can see that from here. Have a look. We've got a big 2 in front of sodium hydrogen carbonate, and we've got no number at all in front of water, which of course means that there's 1 of them. So we didn't start with 2 moles of sodium hydrogen carbonate, but if we did, we would have produced 1 mole of water. Instead, we started with 0.1 moles of hydrogen carbonate. So what we're going to do is we're going to divide that 0.1 by 2, and we're going to get 0.05 moles of water. Like that. So that's the amount of water that we've produced, but we're asked what mass is that. So to do that, what we have to do is multiply 0.05 by the molar mass of water, which is 16 plus 2, which is 18 grams, which gives us 0.05 multiplied by 18, which is 0.9 grams of water. So that's the mass of water produced, like that. Okay, so the next thing that we're asked to do is we're asked to work out the volume of carbon dioxide. So we're going to do that now. We're going to work out what the volume of carbon dioxide is. Again, we're going to use this really important piece of information at the start, which is that we started with 0.1 moles of sodium hydrogen carbonate. So the first thing that we're going to have to do is work out how many moles of carbon dioxide is produced. And again, the molar ratio is going to be used here. And the molar ratio, as we know, is 2 to 1. No number in front of the carbon dioxide implies that it's there only once. So we're going to produce 0.1 divided by 2, which is 0.05 moles of carbon dioxide. Okay, but remember, we're looking for the volume of carbon dioxide. So we should remember that as soon as we hear volume, we need to remember that 1 mole of a gas, doesn't matter what gas, carbon dioxide, helium, oxygen, always occupies 22.4 litres. And we've got 0.05 moles of carbon dioxide. So we're going to multiply 22.4 by 0.05 to find out how many, what volume of carbon dioxide we have. So 22.4 multiplied by 0.05, and that gives us a volume of 1.12 litres of CO2 produced. So that's the volume of carbon dioxide that we've produced from 0.05 moles of carbon dioxide. And the last step that we're asked to do is how many molecules of carbon dioxide is produced. Again, we're asked for amount of particles this time. So when it comes to molecules, what we need to do is multiply the moles by our magic molar number, 6 by 10 to the 23. So the amount of moles that we have of carbon dioxide we worked out from the molar ratio is 0.05. So now we're going to multiply 0.05 by 6 by 10 to the 23 like that. That's really easy to do. And we get 3 by 10 to the 22 molecules of carbon dioxide. Okay, a bit smudgy there at the end. Sorry, can you see that? There it is. So it's 0.05 times 6 by 10 to the 23 gives us 3 by 10 to the 22 molecules of that gas. Okay, so this is a good question to do because it kind of summarizes all of the things that we went through in our introductory video on moles. And if you can do this, you can probably start to move on then to some harder questions in higher level. Good idea now would be to go and find some examples of a similar type question in study clicks or in your papers. Use the template, follow the steps and do these questions, whether you're in 5th year or 6th year, before you go on to higher questions. Okay, best of luck.